Right, good day and welcome. Today we're looking at analytical geometry. We'll start off with gradients, parallel, perpendicular lines, collinear points. Right, very important bolt and your uber etc. can't operate. So first, gradient. Gradient of a line is a measure of how steep a straight line is. So basically, does it have a 40, 50, 60 degree angle? Right, and the gradient of a line can either be positive or negative. So we have negative and positive gradients. It doesn't need to be a whole number. Gradient can be a decimal as well, rational numbers. Right, and a gradient of a line can either be in an uphill positive value or downhill direction, negative value. So uphill, to go from quadrant 1 to quadrant, from quadrant 3 to 1, or from quadrant 2 to 4, downhill. Now in short, we use the small letter m to represent gradient, and that is the change of y over the change in x, or written differently, y2 minus y1, x2 minus x1. Right? Three things we're going to test over and over. Number one, for lines to be parallel, meaning they have the same space between them right through, they must have the same gradient. Right? If we say points are collinear, meaning on the same straight line, they also have the same gradient. If we multiply our gradients of two different lines and the value of that equals -1, then we say the lines are perpendicular. So that's just some basic theory to introduce you to it. Now we're going to look at some problems so you come to understand what I'm saying. Right, now calculating gradient, we give you two lines there. You can see there's a blue line going through A and B. There's a green line going through B and D. Alright, so AB and D and B. Calculate the gradients of AB, BC, BD. So for AB, you see there I've taken A minus 3 and 0, B 0 and 3. Right, so for gradient AB, y2 minus y1, x2 minus x1. So all my 2's I've colored purple here, and all my 1's I've colored blue. So here y2, my y value 3, minus the y value of A 0. B 0 minus 3. So 3 minus 0 gives me 3. 0, negative times negative become positive 3. So 3 divided by 3 would give me 1. For gradient BC, I have to take the coordinates of B, which is 0 and 3, and C, which is 2 and 5. Again, my y2, x2 and y2 I've colored purple, and my x1 and y1 I've colored blue. That is to ensure that we don't make an error when selecting numbers, and that we don't put x by y and y by x. So there, for y2 5 minus y1 3. x2 2 minus x1, which is 0. 5 minus 3 gives me 2. 2 minus 0 gives me 2. 2 divided by 2 gives me 1. Look at the gradient BD. B 0 and 3. x1, x2, or x1, y1, d, x2, y2. So for y2 there, should read 0 minus 3. Okay, 3 minus 0, and then 0 minus 3. I wrote them back to front. So now I've written this as y2, and that is y1. So there, that y value 3 minus 0, colors just have to swap. And then 0 minus 3 gives me 3 over negative 3, which equal minus 1. If I worked vice versa, I would have had 0 minus 3, which gives me negative 3. Then I would have 3 minus 0, which gives me positive 3, which then still becomes negative 1. Right, so that is how we're going to calculate gradient. Right, look at the next. Collinear points. They ask is A, B, and C collinear, meaning are they on the same straight line? So for that to be valid, the gradient of AB must equal the gradient of BC. So we've calculated on the previous slide, gradient AB was 1, gradient BC was 1. So because that gradient is 1 and that is 1, we can conclude that ABC is collinear because gradient AB equal gradient BC. So in exam, if you say collinear, you're going to have to calculate the gradient AB, BC. You see the letter B appears in both of them. That way we check whether they are on the same line. For perpendicular lines, is AB, this line here, perpendicular to PD, meaning there where they meet, do they form a 90-degree angle. So we calculated gradient AB was 1, gradient BD was -1. So if I say gradient AB times gradient BD becomes 1 times -1, which gives me -1. So if I multiply the gradients and it gives me -1, I can conclude then that as AB is perpendicular to BD, or written differently, ABD equal 90 degrees. So that would form a 90-degree angle. For parallel lines, now here they ask is AC from A to C parallel to BD. So for A, I have -3 and 0, C 2 and 5. Here B 0 and 2, there D 2 and 4. So gradient AC, there my purple Y2, blue Y1. Right, so 5 minus 0, 2 minus 3. Don't get caught out with that. Minus 3. The negative was already there, and that is -3. So that's 5. This becomes 2 plus 3, which gives me 5. 5 divided by 5 gives me 1. Gradient BD, Y2, so 4 minus 2, 2 minus 0. 4 minus 2 gives me 2 over 2, which equal 1. So gradient AC equal gradient BD. Therefore, AC parallel to BD because the gradients are equal. Right, so gradients are equal. Then my lines are parallel.